Hi, my name is Kelly Christensen. I'm here at Michigan Tech at the Carbon, Water, and Soils Laboratory, where we are going to show you around and show you how the graphitization process works and talk about radiocarbon dating. But before we go in, we need our PPE. So come on in and we're going to go meet Kate Heckman. Hi, Kate.
Hi! Welcome to the Carbon, Water, and Soils Lab. So my name is Kate Heckman. I'm a research scientist for the U.S. Forest Service. I'm also the primary administrator of the Radiocarbon Collaborative, which is a scientific outreach organization with the main goal of increasing researcher access to radiocarbon analysis and also assisting with interpretation and publication of results. So this is the Carbon, Water, and Soils Lab, and this is where we turn radiocarbon samples into solid carbon or graphite that then allows us to measure its radiocarbon content. So in an archaeological context, the radiocarbon abundance of a sample will basically tell you its age or how old it is. But in a Earth system science context, we can actually use radiocarbon abundance measurements to track the cycling of carbon through different portions of the biosphere, as in carbon turnover in soils, transport in oceans and streams, and things like that. So today we're going to give you a super fast primer on the graphitization process. So that's the process of turning a sample, an organic sample, into a graphite sample for radiocarbon measurement. And to do that, I'm going to hand you off to our lab manager, Paula Semenyo, who's been doing radiocarbon sample prep for over 20 years now. Today she's working on some archaeological samples, which are corn kernel remnants from the Medewan National Prairie. So take it away.
All right, so while that sample was sitting around waiting to be turned into graphite, it picked up a lot of modern carbon on its surface. So the first thing I need to do with samples is I need to clean them up. And I do that by applying a series of acid and base washes on them. I've got a little sample here sitting in some acid as it's going through its treatment. Once I get it all cleaned up, rinse it off, put it on a heat block, and dry it out. So that'll sit overnight and the sample will get nice and dry for me. So once the sample is dried, I'll walk over here to my weigh station, and here I can take my sample. I've got one ready already, and I can weigh my sample out into a combustion tube, and I add, most of what you see in there is actually the oxygen source. And the reason I do that is because we're going to head over to my torching station, if we may. All right, excuse my back. Okay, so I've got obviously air in the sample. So the first thing I need to do is put this onto my vacuum line and expose it to vacuum. So this is going to pull all of the air that's in there out and create a nice little vacuum so that the only thing in here is the sample and its oxygen source. Now, I'm going to need, for those of you looking on, to put on your, you're ready. Safety gear, very important. And this goes fast. I'm going to just use my torch here to seal this sample off while it's under vacuum. And voila. Safe, so we'll get our tanks turned off. Okay, so now that I've got my sample isolated and torched off into this tube, I'm going to put it into a combustion furnace and cook it at 900 degrees C. Now we're going to walk back across this expansive lab. So this is my furnace. My sample will get loaded into there. I'll combust it for about 4 hours, and out comes, guess what? Another sample. This, as you can see, there's no more wood in there. The sample has completely turned into CO2. And there's still some oxidizer in there, but that's okay. So next we come over to my graphite ring. Now this is where the magic really happens. I'm going to take this sample. Now this whole line is currently under vacuum, but I can isolate different ports in order to manipulate the sample. Sometimes you get a little bit of sticky in there. All right. So now I've introduced air to this area, so what I need to do is evacuate it, just like I did on the vacuum line. Now once I get this evacuated, I am able to crack the sample to actually break the glass and release the gas into this cold trap. Now what this cold trap is going to do is it's going to freeze out the water vapor that formed during the combustion of the sample. But it is not cold enough to freeze down liquid nitrogen. I mean, it's not cold enough to freeze down CO2, excuse me. So I need to use liquid nitrogen to do that. Now I can put this liquid nitrogen onto another cold trap. We'll let it calm down a little bit. And when I open up the valve, right in here we should see a nice little pellet form. I don't know if you caught that, but that's our sample right in there. So this is cold enough to actually freeze the CO2 and separate it from the water vapor that was frozen out in this trap. So now that I've got my sample isolated here, I'm going to put it into an individual reactor. Now this reactor has been had some iron added to it previously, and that iron is going to be the catalyst. So I will transfer my CO2 into this reactor now. So now I've got CO2 and iron in this reactor. I'm going to also add hydrogen to it. And then once I apply heat, I've got heaters in here. Once I apply heat to the CO2, the hydrogen will have graphite form. And that graphite is going to form on the iron catalyst. Okay, so we let the reaction go to completion, and what I end up with is a tube that I can pull off the rig cap, and it's got graphite in it. And just so you can see what the iron looked like before, you can see there's a pretty good difference between the iron and the graphite. So now that's not quite ready to go. What I need to do next is to pour that graphite into this tiny little hole that I drilled into an AMS target. So I'll pour the graphite into there, press it, and ship it off for measure. And then we're done. Thank you.
Thank you very much.
You're welcome.
So if you would like any further information on radiocarbon analysis in general or the Radiocarbon Collaborative specifically, please check out our educational outreach website at radiocarbon.forest.mtu.edu. Thanks so much for listening, and I hope you have a great day.